we can study the exponential decay functions to deeply further study the properties of the exponential functions. Okay, we take this expression as an example. Y equals 50 times 1 over 2 raised to x. Here, this is the base. That is, say y equals a times b raised to x. A is 50. B is 1 over 2. X is x. Alright, here the base greater than 0, less than 1. By definition, this base must be a positive number. Sometimes it is greater than 1, sometimes it is greater than 0, less than 1. Here, it is greater than 0, less than 1. So we say it is an exponential decay function. Okay, for this expression, we can use some specific values to figure out the property for this function. First, x, if it is equal to 0, if you plug in 0 here, this power will be 1 multiplied by 50. You will get this number, 50. If this x equals 1, this power will be 1 over 2 multiplied by 50. You will get 25. Go on. If you continue this process, you will get 2, and the y value will be this number. If x equals 3, this y value will be this number. X equals 4, this y value will be this number. All right. Of course, you can use x equal to -1 to figure out 100. You can use x equal to -2 to figure out y value equal to 200. Then you can use these specific points to sketch the graph for this function. That is, say you can locate this point, every point in the Cartesian plane. You can sketch after you connect the corresponding points, you will get the sketch or graph of this function. That is, say this graph will be divided into two parts by this straight line, that is, say the branch below the straight line and the branch above the straight line. All right, this straight line will be y equals 50. Why? Because this is 0, 50. So this straight line, horizontal line, will be y equals 50. Okay. Now, let's examine the graph of this function further. We can make use of two successive y value to figure out the first differences. That is, say we can use this y value and this y value, they are successive. You use 25 to subtract 50. You will figure out this first difference. If you continue this process, you can get the next first difference. That is, say this number will be used to subtract the previous y value. You will get this first difference. You use this number to subtract this previous y value. They are successive y values. So you will get this first difference. Go on. You will get this first difference. If you observe these first differences, you will find out an interesting property. That will say, if you use two successive first differences, if you use this letter, the letter divided by the former, you will figure out the ratio will be 1 over 2. This ratio will be this base. This number divided by this number, it will be the same ratio, 1 over 2. This number is divided by this number. You will get the same ratio. All right? Okay, if you use two successive first differences, you can figure out the second differences. That is, you use this number to subtract this number, you will get this second difference. You continue this process. This number will be used to subtract this number. You can get this second difference. This number and this number, you will get this second difference. Of course, if you use this number, all right, if it is divided by the previous second difference, you will find out this ratio is also 1 over 2. And this number divided by this number, it will be the ratio 1/2. That is say the ratio 1/2. The ratio 1/2. And this ratio is just this base. Alright? Okay. After analyzing the phenomenon, we can summarize the properties of the exponential decay functions. We say, as the independent variable increases by a constant amount, the independent variable that you say x increases by a constant amount, all right, every time x increases by 1 unit, you will find out the dependent variable decreases by a common factor. Decreases by a common factor. The so-called common factor is just the space that you say 1/2. Because this is 50, this is 25 here. It is 50/4, this number, 50/8. All right. The y value decreases by 1/2. Next property, the graph decreases at a decreasing rate. All right. Okay. The next property, they have a repeating exponential pattern of finite differences. That is say the ratio of successive finite differences is constant. This ratio is just this base. That is 1/2. 1/2. All right. This is the properties of the exponential decay functions. You can connect the properties of the exponential decay functions with the properties of the exponential growth functions to understand the properties of the exponential functions. The difference lies in the base. All right. If this base is greater than 1, you can use the properties of the exponential growth functions to analyze the expression. If this base is greater than 0, less than 1, you can use the properties we have discussed here to analyze the properties of the exponential decay functions.